I'm working on a vision-based positioning system for autonomous vehicles for a project, capstone project for a degree that I'm getting. And the way that it works is if you have an area that you want your robots to travel through, and you imagine a grid, imagine it being turned into a grid of XY coordinate system, and imagine that in my system here, which is my basement, I have mapped out, I have this post being 0, 0, and up on the y-axis is going that way. Direction in this, 0 is up on the y-axis, 90 degrees goes to the right, negative 90 goes to the left. And you notice I have certain objects placed, and those are on the map. I have a map that tells the robot where things are. So for instance, this house, there's a house it can find at negative 71, 75. So I have that right here. And these little tape marks, the car doesn't pay attention to those. Those are just for me to help visualize as I'm doing things, where I am, so I can see how accurate it is. And so what the car does, it's got cameras where it looks for things, and when it recognizes something, it checks if it's on the map, and if it is, it notes where is that on the map, and then where do I see it, and how big does it look. So it combines all of that to come up with a position where it believes that it is, and a direction that it believes that it's facing. So that's mainly the project. Up until now, I have been manually pushing a car around because I didn't want to get into the mechanics of actually driving the car. So I have other videos of me pushing this car around and looking at the coordinates it comes up with. I have, to help me get this working, I have an app that lets me interact with the system. It works with more than one robot, so I can see where the robots think they've been. I can see what they're seeing that's helping them determine their position. There's little boxes telling what those are and how far away they are. I can also see a map showing me where the thing believes it's been, where landmarks are, things like that, and I can assign it tasks. And so I use this to, up until now I've been using it just to test the accuracy of the coordinate calculations. So this past week I got into actually trying to do something a little more useful, which is drive the vehicle around and get it to do things. So over the last couple of weeks, I was manually pushing these vehicles around and having them collect their measurements, log it, and what I was trying to do was push it through different areas of the map and see where there might be dead spots or problems with the calculations. So I was basically trying to make an N show up on the map. And so the first time I did it, when I thought it was going to be pretty good, it was pretty terrible. After a lot more work, I ran the same test a few times, and it was bad, but not as terrible. And then finally, I got the calculations working pretty well. So with those calculations working pretty well, I decided to go ahead and start trying to do something a little more useful. After that last set of tests, I added several more enhancements. I added multi-threading in a few places, and to speed it up. I spent some time trying to tune the vehicle's movement a little bit. so that its rotation will be more accurate and calculating its distance that it travels based on wheel rotations and things like that. So when I had that where I thought it was pretty good, I did this test where I had a pineapple, fake pineapple, that I stuck over to the side of the room where the vehicle probably couldn't quite see it unless it went to that area. And then, so I'm going to end up doing an area search where a vehicle or a set of vehicles will decide how to divide up the room or area and go through it in some sort of pattern and mark where they find things on a map. So that's where I'm headed. But for now, to make sure the simpler parts work, I went ahead and suggested the vehicle where it should go and told it, then once you get there, search for a pineapple, and if you find it, take the LiDAR measurements of the area, take a picture, things like that. So I went into the app and told it some XY coordinates to go to, and additionally gave it those other commands that I told you. So then the robot woke up and traveled over there, and it seemed like it did a pretty good job. So as I look through the images that were used for positioning, that's useful for me to look at because if there were any trouble with the calculations, this really gives me a clue what the problem was, and I can look further into it. It seemed like everything went really well. And these images look good. Well, it did miss that light. I think maybe the reflection confused it there, but it got enough of other things to get a position there. Yeah, that one's good. And the dotted line you see is the LiDAR going around. So these look pretty good. Here we go. Yeah, that's better. Oh no, that one's a little off. This is where I kind of kicked it. I did two tests that I consider good tests. One of them, I just sat the vehicle, let it do its thing. It went straight to the coordinate, as you would expect, and that was a little boring. So I did the same test, gave it a nudge with my foot as it was in the middle of positioning. So then it had to, then it took a different path, and this must have been right after I nudged it with my foot. So that's fine. That was expected, I suppose. And yeah, the rest of these look pretty good. That's not so good. Apparently that didn't interfere with the calculation too much, but yeah, there's a miss there. But overall, yeah, the test went really well. So if we look at the app results, yeah, this was all good. I was refreshing this on my phone as it did its thing, and they looked good. These are some of the same images we just looked at, and it did find the pineapple, as you can see right there. And if I look on the map, the green dot, so this is the path it traveled, and the green dot is where it thought the pineapple was. And I think the blue is all LiDAR, and I believe this must be where I was sitting. I realized these PI cameras actually have they're nice cameras, and I was cropping it down to a size that I could easily scale to feed it into a model. And what I realized is I was throwing away a lot of valuable information. So for instance, if I look at, so that one's awfully close, so that's not a good example. But the camera can actually have a lot wider field of view than this, and I was cropping it down. So I was doing some tests today with it. Yeah, you can see I've got a lot wider of a field of view, and so I shouldn't have to move the cameras as much. There's that same shot almost. I think that is the same, and you can see it's pulling in the extra landmark there. So this should definitely help. Over the next couple weeks or so, what I'm going to be working on is I already have code that will take an area and divide it up and assign tasks to multiple robots to do a search, but I've not tested that. So I'm going to start testing that, and in order to test that, I actually need another robot that can move around. So I have a tank that was working at one time, and I'm going to get that working again. I have to put a Jetson Nano on that, and I'm not sure what else it'll take to get that running again. So if things go well in the next few weeks, I should have a multi-robot search system working. So we'll see.